once you are done with your factoring practice there, go ahead and check what you've done. I think the one thing I always want to point out on differences between B and D, both of them had a greatest common factor. This one had a greatest common factor of 2. This one had a greatest common factor of x squared. One of them that gave you an answer and one of them it didn't. Why did the 2 in B not give me an answer?
Because 2 equals 0. You can't do that.
Because 2 does not equal 0, and it doesn't have a variable, and I can't solve it. But if there is a variable in that greatest common factor, you do have to set it equal to 0. So don't forget that. That's what gives me the 0.
What if it was 0? 0 equals
0. 0 equals 0? I don't see how that would happen. Because that would be a greatest common factor of 0, which doesn't really work. All right, any factoring issues? We're at the place with factoring. If you can't factor quickly, come see me. We'll figure it out. But we're not going to be doing it that much more, okay? All right, next section, real quick. There are 2 ways to solve the same problem. Okay, this is how we get into our other methods. What is one way to solve x squared equals 16? Square root both sides. Which gives me x equals what? Plus or minus 4. Good. This is the place in this test and the quiz that is over this solving that you will lose half of every question that involves a plus or minus if you forget it, because you're losing half your answers. This is a very simple question, but if you only say it's 4, you're missing half of it. So make sure that you get the plus or minus in your head for the square roots. What's the other way we can solve this? Move the 16. Yes. Move the 16 and do what with this? Well, in this case, this is difference of squares, right? Factor. X plus 4, x minus 4.
Why would you do that?
Just because you could think about it 2 different ways.
Is that method piece like this method? Is that method number 2?
Well, that was factoring, so that's method number 1. The square roots one is kind of where we're going with completing the square. If something doesn't solve by square roots, you can force it to solve by square roots, which is what we're going to do on the back. Okay? Completing the square tends to be the one of all the 4 methods that we just kind of forget and we don't want to do. On the test, just so that you are aware, the way I've set it up, there's a couple questions that I tell you you must solve these by factoring. There's a couple questions you must solve by square roots, must solve by completing the square, must solve by quadratic formula, so that I can see you know each of the 4 methods. Then there is a section where you may choose. Okay? If you can choose what should be your automatic go-to, no matter what, factoring. If it doesn't factor, then you pick. Most of you would go quadratic formula. Because quadratic formula, now oddly enough, completing the square is the other one that will work all the time. But no one chooses to use that. We choose to use quadratic formula. So, it's not as bad as you want to make it out to be. But the reason we do it is so we can force things to look like these last 2 problems here. These kind of problems, the last thing that I want you to do is to FOIL that out, move everything to one side and factor. That's not what we're intending on this. Mostly because sometimes that won't even work. And then you'd have to use quadratic formula on it and you've made a mess. Rather than do that, we would like to square root both sides. Make sure that we know that this is plus or minus 4. And then how do you get x by itself? Add 2 to both sides. Now, there are 2 different cases here. In this particular case, can you give me 2 separate answers? Yes, it's very easy. 2 plus 4 is 6. 2 minus 4 is negative 2. If you can do that, because things square rooted nicely, please do it. If you can't, like B, you can leave it as the plus or minus. Okay? The reason B doesn't work is because when we square root both sides, can we square root 3? Nope. So we leave it as plus or minus root 3. Where do we put the 1 when we subtract it? In front. The type of answers that you get also tells you what method you could use to check this. So if I wanted to, I could check A in a different method. I could FOIL it out, move everything to one side. A would work with factoring, and I know that. Why? What kind of answers did I get? Nice. Whole number answers. Even if they're fractions, that means they would have worked by factoring. The only time it doesn't work by factoring is if you get a root in it. Okay? So I know that I can check everything by factoring if I get whole number answers. You may have time and want to do that on some of these methods. It's up to you. Now, completing the square on the back, I'm going to walk through slowly with you. And I'm kind of rewording these steps the way that I kind of go with them. I should have retyped it, but I didn't. All right. Step number 1. When it is in standard form, we move the C to the other side first. Okay? Our goal is to force this to factor into something that looks like those last two problems so that we can solve using square roots. So step number 1 here on A is to move my C term. How do I move the 8 to the other side? I add it. Now I leave myself a nice little blank right here because I am going to force this to factor by adding in a particular C value in place of that 8. So what we're going to do every time is we are going to add b over 2 squared to both sides. Okay? We always have to add to both sides because we are algebra students and we do the same thing to both sides every time, right? Now, I am going to show my work here, and you will see later in the class period why I show this step every time. First, I know that you know the formula because you're showing me b divided by 2 squared. What does that mean I'm adding in that blank?
4.
Plus 4. If I add 4 there, where else must I add 4? On the other side. Okay. Later on, if you are dealing with fractions, showing that step will help you to factor. And that's why I'm doing it. And I'll show you an example of this. Okay. Now, step number 3 for both of these is to factor and solve. Take a look at the left side. What does the left side factor into? X minus 2, x minus 2, right? Or squared. You are always going to factor into 2 of the same parentheses, which we are going to write as squared. Now, when you factor, normally I don't care, but the point of this is that we can use square roots to solve. So in order to do that, I do need to write it as squared. Now from here, it's pretty simple solving using square roots. Completing the square, that process forces it to factor this way so that you can solve kind of nicely. So from here, square root both sides. Can't square root 12 directly, but is there something I can take out of it?
2.
Okay, I can take a 2 out, leave a 3 in, right? And then our last step would be to move the 2 and put it out front. And you will not be able to combine like terms because this is a whole term, right? That's not a like term with the other one. Is this process vaguely familiar to us?
Yeah.
Kind of?
I'm confused on how you made the jump from the x squared minus 4x 4 to
The x minus 2 squared. I asked myself, how does x squared minus 4x plus 4 factor? So x minus 2, which we write as x minus 2 squared.
Yeah, but when it gets like really more complicated, it's like a faster way.
Yes. Remember how I said that this is a step that I always write right here?
Yes.
What number does that reduce to? Negative 2 specifically, right? That is always the number that's going to be in here. It is always going to be x and that number squared every time. Always. That's what you're forcing it to be, so it will always be that way, which is why I write this, because if it's a fraction that's kind of nasty, I don't even have to think about it. That's going to be what it is every time.
Not the squared, though.
Not the squared, just what's inside. All right, so now let's try that with B. With B, depending on who taught you last year, I'm seeing a distinct difference between the two teachers. You were either taught to get rid of the A value or factor it out. If you are a factor it out type person, you may continue to do that. I am not going to teach it because there are things that you have to do in order to get it right, and if you don't do all the things, you're not going to get it right. So what I do, and I kind of add this to step 1, is I move C and divide by A all at the same time. Now, why did I not do that in the first one?
You didn't need to
I didn't need to. It was 1, right? All right. So in B, let's do the same process again, and then we're going to practice some, because this is the one that we always need practice with. I move my 13. Here is where I would just divide by 4 to get rid of it. If you divide by 4, you got to divide everything by 4. Yes, that makes a fraction over there. We're going to deal with it. Okay? Some people will feel more comfortable factoring out the 4, and like I said, you can get it right. It's just a little bit harder. So following my completing the square process here, I'm still going to take my b, divide by 2, and square it. Notice that I'm not taking 24 and dividing by 2 and squaring it, because we divide the a first. You got to get rid of that a value before you do this step. That means, what am I adding in the blank here? 9, which is what I'm also adding to the other side. What is 9 in terms of fourths? 36 over 4. Headed into the next step, I go ahead and factor. I can either look at x squared plus 6x plus 9 and see what it factors into, or I can look at this 6 over 2 and say that reduces to positive 3. Therefore, it's always going to be x plus 3 squared. Okay, what else do I have on the right now? Okay, now I should feel slightly okay about that fraction. Anyone know why? Because I can square root both. So it's not as bad as it looks, right? So I can square root both parts of that. So going into my next step, I'm just going to square root to solve. That gives me x plus 3 is equal to plus or minus what? 7 over 2. Now, am I going to be able to get nice answers out of this? Yes, because there's no more square root, right? I can add these and subtract these. When I subtract the 3 in terms of halves is negative 6 over 2 plus or minus 7 over 2. So what's one answer that I get from this? 1/2. The other one? Negative 13 over 2. Now, okay, those are what I consider to be nice answers still. Yes, they're fractions. No, we don't like fractions, but they are still, quote, nice answers because they don't have roots in them. That means if I wanted to, if on the test maybe I'm a little bit concerned about my completing the square, how could I check my answers? What method?
Quadratic formula.
Well, you could, but easier than that. Why do I know that that factors?
Because they're both fractions.
Because they're fractions or whole numbers. It has to. If there's no square root, it has to factor. So even looking at that, I know it's going to. Going back to this real quick, just check by factoring. I know you laugh at me saying check your answers, but very easy to do on this one. What are my factors of 4x squared? 2 and 2. And looking at my answers, how would I know that 2 and 2 is right?
They're both the denominator.
That's the denominator of both of these. Okay? Factors of negative 13 would be 13 and 1. I just have to decide what's positive and negative. It has to add up to positive 24. So that means I want the 13 to be positive, the 1 to be negative. Would those work out to the same answers? Yes. So that's a very, very quick way to check your answers. I might not check them if they're square roots because I don't like quadratic formula that much. But
And the first question was minus, like
Mhm.
minus 2 squared,
Mhm.
and the second question was x plus 3.
it depends on the sign in here of the b value. That was negative 4 over 2, which reduces to negative 2. This one was positive 6 over 2, which reduces to positive 3. Okay? All right, see what you can do with C on your own. Let us say we are on, a multiple choice test that has multiple choice answers and this does not show up. Does this mean you're wrong? No. It's not considered proper. Remember we talked about in math to leave a square root on the bottom. I will not make you on a written test leave or go anywhere from here. You could leave it here. I just want you to know how you would check your answer if you did not see yours, because this does not mean you're wrong if this is not there. This is the same as this right here, right? Square rooting both. And you could simply do what we call rationalize the denominator, which is multiplying by root 3 top and bottom. What is root 2 times root 3? Root 6. What is root 3 times root 3? Root 9, which is what? 3. Okay? The point is to not leave a square root in the bottom. That's why we do the root 3 times root 3, right? So this is an equivalent answer to the one that you have. They look very different though, right? Okay? So if you don't rationalize, it's fine for me. But if you don't find your answer on a multiple choice test, please know how to either switch it to this form, or what's your other option on a multiple choice test with a calculator? Plug it in. Type this in, see what decimals you get, go through your multiple choice answers and see which one gives you the right decimals. That works too, as long as you know how to fix the issue. Okay? Try this once more on your paper on D, and then we're going to get up and practice with whiteboards.